Your homework was Unit 13, Gears, Lesson 4. Let's go straight to this question here. No, not this one, not this one, this one. So, FYI, facile learning sometimes is a little more than what you need. So if you feel it's too advanced, no worries. In grade 9, the gear stuff is really just qualitative, meaning look at the size. Is it bigger, larger? Is it bigger, smaller? And describe the speed. It's really just that, okay? So here they might have done a little more than that. Like here it talks about if it talks about 10 revolutions per second. This is a little more advanced than what you need. Okay. So let's just take a look at this question number 5. Let's see if you remember doing this quiz. Gear 3. It's asking about gear 3. Okay. It says, does gear 3 turn slower than gear 2? Does it turn faster than gear 4? Does it turn slower than gear 1? Or does it turn slower than gear 4? So let's hear some of your answers. Harry, are you there? Harry? Harry disappeared. Slower than gear 1. Yes. So thank you, Dana. This number 3, this one, the third answer. Yeah, so if you take a look real quick at what we did last time, we looked at the size of the gears and we looked at how in relevance to like, so gear 1 is going faster than gear 3 because it's the smallest, right? And so on. So I'm going to ask you guys some more questions. I'd like to hear your feedback on the chat. Which of these gears tends to go the slowest? Let's hear your answers.
Is that working?
I hear you. Oh, hey, how are you?
I don't know what happened. I just joined and then it kicked me out.
Oh, it did?
Yeah, I don't know why, but I'm in now, so.
You're here.
That was weird.
Peter.
Anyway.
Write your name down. So, Peter, we are just reviewing now the assignment of the week, and then we'll move on to review of the older stuff in engineering.
Okay.
Do you see the screen that I'm sharing?
I do not.
Or you see your face right now?
Yeah, I see myself.
See your face. Okay. Now you see this.
My screen is kind of frozen now.
You see the gears?
No, I still see me, and I'm frozen.
Is that only Peter? Dana, do you see the screen?
Yeah, I see it.
Okay. Peter, maybe you want to
screen.
do you see it? Okay.
Oh yeah, no,
all
I
right.
see it.
Okay. So question for everyone. Which gear is going at the same speed as gear 3? Let's see your answers. Which gear is going at the same speed as gear 3? Yeah. Excellent. And yes, very good. All right. Name a gear that is going faster than gear 3. Yes, very good. Good. Yes. Look, it says here, if the wheel is turned 4 times, the axle will turn how many times, you think? Look at the axle is way smaller. So how many times do you think? Let's see your answers. If the wheel is turned 4 times, the axle will turn. Oh, Chris, can you explain why you said 4 times? Peter, why do you think 8? This is a tricky one.
Why do I think 8? Well, the axle is a lot smaller, so like the diameter of the axle is way smaller than the wheel.
Yes, but the only thing that we need to make sure of is that you see the axle, I believe in this particular situation, it's stuck to the gear. It's stuck to the wheel. So if the wheel is turning 4 times the axle too, let's see. It should rotate the same. But then
Okay,
you
so
yeah,
so it's connected to the same part.
Yeah, exactly.
Okay, that makes sense.
In
I
here.
didn't see that.
Whereas if it was on the outside of it, like on the side right here, then you would say it would go faster. It would spin 8 times. Yeah. Okay. Good point, guys. Okay, what else did we do? So that was the main thing on gears. Can I get a 5 or a 3 if you understand the gears? 5 or 3? Let's see. Okay. All right. Okay, I'm getting bombarded. Sure, no problem. Like the bombardment of answers. That's good. Let's hear. Let's see if you guys then, let me get those images again. They keep disappearing on me. Where are those images? There's so many images. Aha. No, I need one with the bicycle. Where did it go? My bicycle image. It's okay. This is close enough. Right here. Okay. Let's say let me turn it around. There, that's more what you would see. So on the right, the gear is attached to the pedals of a bicycle. On the left, it's at the back of the bicycle. So the way it is placed like this, would it speed up or slow down?
Miss, are you screen sharing?
You don't see it?
No.
There, now you see it?
Yeah.
Okay, so I'm going to repeat my question differently a little bit. Let's say this is on a bicycle. You have the right side that has the pedal and the left side that's in the back of the bike. Okay? Which of these two is the driver gear? Driver. Which one is the driver? The one with the pedals or the one in the back? I need to find the image with the pedal. Well, let's see your answers. I don't see no one answering. Yes, with the pedals, yes. You drive. Remember, the driver is the one that's in charge of the movement. So if you are the driver, the big one, yes, Peter, thanks. We should have just said that, bigger, smaller. So Peter, yes, the bigger one. In this case, if you're in the situation, imagine you're in a bicycle, the one with the pedal is the one that is the driver. So that explain now, you guys, the smaller gear here in this case, would it be faster, slower, or the same as the big gear? Let's see your answers on the chat. Would it be faster, slower, or the same as the big gear? Thomas, that's not an acceptable answer. What's your answer? What do you think? The smaller gear, would it be faster or slower than the bigger gear, Thomas? Neither. So it would be faster. And now I'm kind of doubting if everybody understands this. I'll show you. Right here. What did he answer? Nicholas said faster. Okay, most of you got it. Oh. Let's see. Why did Thomas write neither? Gears. Go back to the other one. Share the screen with you, then you see what I mean. Probably wondering, what am I doing? Here we are. There we go. There we go. There. Got it? Let's exaggerate this with bigger teeth. Got it? So you got the blue one, that's the driver on the right side. And the left side, the smaller gear, is going way faster. In fact, 6 times faster. Got it? All right. Thomas, can I get an okay from you? Do you see why? The smaller the gear, the faster we'll go. Okay. All right. Thank you very much for that. So the next thing I wanted to review with you guys is something we did in the beginning of the year. It feels like a decade ago. Can we go to page, if you have your blue notebook, page 83 in your blue notebook, page 83. So if you do not have your notes, I need you to pay attention. I posted all of the notes on engineering, and I'm going to show you right here where to get them, in case you don't know where to get them. So when you go to materials and Schoology, and you go engineering, chapters 11, 12, it's here. It says all tech notes. Got it? So if you're missing anything, you can go back. It's all there. Everything's here. Okay. So far, just a reminder why we use the lines. Architects, engineers need those lines. They need to have a common language, and anything you can think of, down from like a cup, has to be thought out, has to be designed before actually executing, before manufacturing the object, right? So and everything has a dimension, everything has a visible line, all kinds of things. Objects must have these particular diagrams. Okay, so if we take a look at diagrams, not this one, hold on, like this one. Do you see it?
Yeah.
This is an old image of the Champlain Bridge, and if you didn't have all these details, it would be really hard to know what these numbers represent. Okay, there's a better image. There's the one with the iPhone, the image of the iPhone. Oops. The iPhone image is right here. Let me just zoom in a little more. Here we go.
Yeah, it showed it to us in class.
Yes, but feels like a while ago. Do you remember?
Yeah.
So you remember, like, all of these lines, if you didn't have the lines, it would be really hard to understand where these numbers go. What is that? 51.70. This is from where to where. So that's why you need, for every line, you need an extension line that extends all the way to the part of the image you're trying to represent. All right. So out of curiosity, let's see in the chat if you can answer this question. The numbers here, are they in millimeters or centimeters? Let's see your answers. What do you think?
Mm.
Do you remember this, George?
millimeters, I think.
Yes, millimeters, definitely. Common sense, this is not going to be 51 centimeters wide, right?
Yeah, it's the smallest
The
one.
51 millimeters. So,
Yeah.
and just to make things simpler and easier and lighter to look at, we remove the units. But you have to keep in mind, they're all millimeters, okay? Okay, I'm going to be pointing at a line. Let's see what you remember. This line here, what is it called? Look in your notes. What's this line called that I'm pointing at? You see the arrow? I mean the mouse? Let's see your answers.
Dimension line.
Yes, very good. Yeah. Excellent. Then what's this one then? The long one right here. Yes, extension line. Excellent. Okay. Yes, extension. They always go hand in hand, by the way. It's always together. Okay. What else we have? So that was page 83. Any questions on page 83? No? Okay. Oh, there's a question. Let's see. Oh, no. Okay. Page 84 was projections. So projections. Let's see the images right here. So just a reminder of how we look at objects. So either we're looking at them where you can see two faces at a time. And this is what we would call isometric, where you see the angles. This is not shared, is it? Is it shared? Right here. So on page 84, we're looking at angles. We have the angles here. Both of them are equal on both sides. Hence the name isometric, iso being equal, and metric meaning measurement. So equal angle on both sides. And it looks like it's on the tippy toe, standing on the surface. Whereas oblique, you see one face and everything else is projected behind. All right. What else? But you guys were very, remember we did the drawings of this on SketchUp in the beginning of the year. We drew the birdhouse on SketchUp and you guys were very creative. I was very impressed with everybody, which I really miss. I miss doing that kind of stuff. We had a cross section. Anyone tell me what is the purpose of a cross section? Why do we do cross section? Well, I'm going to have to choose someone. You're all very quiet. Why do we do cross section? Ferris. Let's hear Ferris. Oh, we have an answer. Wait, miss. Wait? No, I don't have time to wait.
What was the question?
The question was, why do we do cross section?
To see like what's inside.
Yes, to see, to understand the functioning. That's why, especially in biology, there's a lot of cross sections. When we do the cross section of the heart or intestine, anything really, you want to see how it functions. Very good. Next is page 86, exploded view. Exploded. And I saw, actually, since Peter's on the line with us, I was looking at an exploded view of a guitar. Did you ever look at that? Exploded view of a guitar.
Exploded view, I don't think so, but I know what's inside.
Uh-huh. Well, let's take a look at an exploded view of a guitar. There we go. You see? Let's pick that one. Ooh, looks complicated. So
Yeah, that's about right.
Yeah, what would be the purpose of an exploded view? Why do we care?
Well, just to see how many different parts go into building an object and like where they go.
Yeah. Where they go, exactly that. Can you guys think of, like, have you ever used or seen a catalog that has an exploded view of something? Did you ever build stuff at home? Peter? Or anyone else? Yep.
Well, I remember when
Building
my
a
brother was
house.
building a Lego set, in the instructions, it was kind of like an exploded view.
Right. Fabio here said IKEA furniture. Yep. Dana
Yeah,
said
that too.
cars.
That too.
Exactly. So, I mean, some are simpler, like more user-friendly, like the ones IKEA show. It's more user-friendly. And some are really technical, like this guitar image. And you name it. I'd say all, if you search up, most machines or objects, whatever, have a technical, have an exploded view. And so like a technician who's used to looking at these would know where to place what for the guitar or for any other object. So it's really interesting to see where, okay, yeah, this screw goes into that, and then it goes into this, and blah, blah, blah. And then you have all these numbers, which means that somewhere else you'd have instructions, and every number would have a name. So it's very, very detailed. Okay? But
Well, that's
for
a
sure,
hollow body guitar, so it's a bit more complicated looking, but
yeah,
it's
for
more or
the
less the
electric
same.
guitar,
Well, that it is electric, but it's
yeah,
just the body is hollow, so that if you play without plugging it in, it's louder because
yeah,
the body is hollow.
yeah,
So it's kind of like a mix of both acoustic and electric. That's why it looks a bit more complicated,
interesting.
but it's not that different.
Hmm? You see here, there's a simpler exploded view of a guitar, and it's not as, like, it's probably like if you had to assemble a guitar that's partially deassembled, this would be the exploded view, you see? Okay, next is the scale, page 86. The scale on page 86. And right here. Page 86. Over here. So I need you to highlight in the scale, the first number on the left is the length of the drawings, the actual image that you draw. And the second number is always the actual object. Got it? So whenever we're doing any of this, so let's take a look at, again, the image of the iPhone, for example, this one. If I go back to this, you have scale written down somewhere. Where is it? Oh, right here. See that? So who can tell me? It says here, I believe this is the jack for inserting the charging cable, right? It says scale 2:1. Who can tell me? Is this a reduction scale or enlarging scale? What do you guys think? You can write your answer on the chat. Is that a reduction or enlarging? Yes, scale increase. Yes, because the 2 here is the image that you drew, and the object is 1, which means the object is smaller than this. Okay, excellent. Yeah. All right, now who can tell me in what situation would I need to use a scale reduction? A scale reduction. Give me an example of something I would need to draw for a scale reduction. Let's see your answers. Yes, drawing of a bridge, a car, a house, definitely a boat, a building. Yes. Anything bigger than your paper, basically. A building. Yes. Very good. Oh, there's something we use in biology. Now go back to scale increase, scale increase. in biology. Where and how? In biology, when do I use a scale? Yes, Georgia said cells. Good job, Georgia. Yes, you know when you use a microscope and we do, it says scale 400. Do you remember that? That would mean that the cells that I'm looking at are actually like, it's 400 times smaller than what I'm looking at. Okay, very good. Okay, so far, how are we doing? 5, give me a 5 or a 3. 5, do you understand? 3, so. So just a review, eh? We're just skimming through it here. George, yeah. I don't see Harry in here. Did he leave? Elena, 5, good job. Okay. All right, next was dimensioning, page 87. Again, symbols that help lighten up the drawings. So, for example, let me see the, hold on, where is it? Hold on. Oh, this one. Who can tell me what does capital R stand for? Capital R. Let's see, page 87.
Radius.
Yes, the radius. Excellent. Again, just to simplify make it lighter a little bit, because if we start writing radius every time there's a necessity to write radius, it would be too much to write. It'd be too crowded. Already, it's very crowded as it is. So you see the detail? They're looking at the radius of half circle of that little charging dock right here. The little radius of this little thing here is 3.4 millimeters. And times 2, because you have 2 sides. See how small that is? If your phone is near you, look at it. It is pretty darn small. 3 millimeters. It looks pretty accurate. Yeah. Okay. Something else you see right here, those double arrowheads represent what? Let me see your answers on the chat. Let me see what. Those 2 double arrowheads, what does that mean? Anybody? Yes. Degrees of the angle. Yes, so 100 degrees for the home button, which I'm not sure how that makes sense. Recording video is blocking. Everybody see it? Peter, is it good? Can you see?
I do see it, yeah.
Okay. I don't know what you're talking about, Deanna.
We all do.
Okay. And lastly is the circle with the line in the middle. What does that mean? Anybody tell me?
Diameter.
Yes. So if you can see, I think that's the little screws. Oh my God, it's so tiny. They are 1.8, 1.6 millimeters and times 2 because you have 2. See that? Very good. All right. If you take a look at the image, there's so many, like you see how many times they mention the angles for the flash, for the rear camera, for what else? The front camera. It's very detailed that way. Good. And the last one for today is page 87, tolerance. And that one, I feel like I want to give you an example from an old exam because it's not as straightforward. If we go back to the notes on Schoology, page 87, do you all have the answers to that?
Yeah.
Yeah. So just a reminder, because it's a while ago, if I have the hole for, like, this is a test tube rack. So I have these openings, and the way to read it, if you remember, it's 10, give or take 2. So the diameter of the hole is 10, give or take 2, meaning it can fit anything between 12 and 8. You see, we drew it here. Minimum dimension 8, maximum dimension 12. So you add or subtract. Got it? So if I have a, let's see, a test tube that is 14 millimeters wide, will it fit? Yes or no? Let's see your answers. Will it fit? Yes or no? I have a test tube 14 millimeters wide. Okay. Exactly. Will not fit. Very good. And what about 6 millimeters? So Peter said, oh yeah, and Dana, it's too small. So it can fit. It will go through, but it will go straight through. It will fall. And it won't serve the functionality like of the test tube rack. The test tube rack is supposed to allow the test tube to fit and not fall. It's a support. So if your test tube is way too small, then it will fall and all the contents will fall or the test tube will break. So it will not serve the purpose that it was meant to serve, which is to hold the test tube. Okay. So that being said, I'm going to do one question from an old exam. Okay. I want you to look where I got this. Pay attention to my screen. If you go to the June 8 folder, which is this week, I posted an exam, the section C of the exam, right here. So that's your homework for this week, by the way. I'm going to answer one question with you, if you haven't done it already. I'm going to go all the way to the last question. So if you have a pen and paper, please take it out. Or if you actually printed this, please take it out. I'm curious to know who printed this. Not many printed, eh? Let's see. Nobody printed.
Not yet.
Not yet. Oh no. It's okay. Do you have a pen and paper? Yeah. Diana, let me hear your lovely voice again. Can you read the question, please? Well, Diana, where are you?
I'll gladly read it.
George? Okay, Diana, maybe next time. Go ahead, George.
When manufacturing the fan, the appropriate size screw must be made in order to fit into the drill hole in the housing until the fan blades component 2. The rear section of the housing unit has observed from the front of the fan is illustrated below, referred to Appendix 1.
Yeah. So, imagine you have a fan. You know, you're looking at the fan. This is in front. And you have 3 screws. 3 holes to enter the screws in so that it would fit, you know, the casing of the fan. It looks like this. Look. The fan looks like this. Hold on. Voyons. Right here. So we're looking at it frontwards. And you have 3 holes to fit screws. So the grill goes on top. Okay? All right. We'll go back down. All right. So, guys, first thing you do when you see this means what again? What's that symbol again?
Diameter.
Yes. So the diameter of the hole is 4.1, give or take 0.2. Okay. Can you guys calculate what does that mean? What is the range of the hole? From what to what? A reminder, you got to do 4.1 minus 0.2 and 4.1 plus 0.2. What is my range? Go ahead and write it in the chat. Let's see. Yes. Valentine said 3.9 to 4.3. Yes. You guys write this down because it's going to get confusing. Please write it down. Okay, so just bear with me here. Imagine I have, everybody see here? I have a hole, this one, and I'm trying to fit a screw inside, okay? Would you agree that this hole has to be slightly larger to fit the screw? Got it? All right, so now back to the question. Now what? It says, the table below provides information on dimension and tolerance for 4 screws. You have to choose one of these 3 screws is the proper one to fit inside this hole. Okay? And then it says, which screw should the manufacturer use to attach the housing unit? Explain your choice. Screws with a diameter less than 3.4 will not function. The appropriate size screw is blah, blah, blah. So you have to figure out which one of these 4 is a proper screw to fit in the hole. So I'm going to give you a minute, okay, to figure out all 4 screws. I need you to do the same thing we did. Find the range of the size. Here's what I'm going to share the smart notebook with you. 1 second. So to start with, the hole, the range is for the hole anywhere between 3.9 and 4.3. Okay, screw number 1. It says 3.2, give or take 0.8. I'm going to do the first one, then you have to do the rest. I'll give you a minute to do it. It says 3.2, give or take 0.8. This means the range, the size of the screw is anywhere between 2.4 and 4. See what I did? I did 3.2 plus 4, plus 0.8 and 3.2 minus 0.8. Okay, I'll give you a minute to do the rest. Find the range of 2, 3, and 4. Screw number 2, screw number 3, screw number 4. Screw number 2 was, it says 3.4, give or take. Here it says 3.7, give or take 0.1. And this one is 3.9, give or take 0.5. There, I give you a minute. I need you to figure out the range of the sizes. Go ahead. I'm just gonna get my jacket. I'm getting cold. So, we have an answer? Okay, so let's see who is in the chat. Okay, I just hung up on your faces. I'm sorry. Okay, so on the chat, I have Sharos. You there? So, Sharos, can you find the range? 3.4, give or take 0.6. What's the smallest dimension?
$2.8.
Yeah, so you did 2 minus 0, so
Yeah,
3.8
I did
minus.
3.4 minus 0.6.
Yeah,
And then
and what's
4.
Yeah. Yes. 4. Okay, who's next? Who wants to do the next one? Nicholas? Anyone else would like to pitch in? Stefania?
I'll do it.
Okay, go ahead.
All right, so 3.7 minus 0.1, 3.6.
Yep.
And 3.7 plus 0.1, 3.8.
Yes. And number 4. You want to continue?
Me again?
Sure.
Okay, 3.9 minus 0.5, 3.4.
3.4.
Yeah.
And plus 0.5, 4.4?
Yep.
Yep.
All right. So now what? We have the dimensions of the screws. We have the hole. Remember, the hole has to be slightly larger than the screws. So which of these would be best fit? And it says if it's under 3.4, it will not work. So let's see your answers on the chat before I reveal the answer.
The third one.
Yep.
Número
Good.
3.
Is that George?
Yeah.
So why? That's very good. Why? Excellent.
Well, because first you can be under 3.4, so 3.6 is over 3.4.
Yeah. And what else?
And wait, can you go up a bit? And because the 4.3, the 3.8 is like, it's the same, like, I'm not sure how to explain it.
It's a little smaller than 3.9.
Yeah, yeah, exactly.
So these two won't work because of this. 2.4,
Yeah.
2.8 is too small. But what about this one?
Well, it's 3.4.
Yeah, it's the same size.
Yeah.
But it's also this the problem. You cannot have a screw bigger than the hole. Then it's not going to fit. Common sense?
Yes, ma'am.
Okay. That's good. So yes, the answer is 3. So can I get a 5 or a 3 if you understand this exam question? Okay, good. Excellent. A lot of kids have a hard time with that. So we can, I'll post some more questions for sure on that stuff. And the last thing for today, before we do the Kahoot, I promise you, last thing, is page 102. Can you skip to 102? And I'm going to ask you some questions. Let's see if you remember. All right. So on page 102, 103, we discussed electrical engineering. if you don't have the notes, please go to my Schoology account and the engineering section. It's going to be in there. So we saw 4 main things, basic things that are part of a electric system: power supply, conduction, protection, and control. Who can tell me a switch? Which of these 4 functions does it serve? A switch. Let's see your answers. Come on, guys. I need more answers than that. It's only 1 person or 2 that answer all the time.
Control.
Yes.
It's a switch.
Excellent. Okay, what about, who can tell me a battery is part of what? Which function does it serve? A battery.
Power supply.
Yes. Okay, how about a copper wire? Copper wire.
Copper wire. Conduction, I think.
Yes. Did you have the notes of these, George?
What's that?
Do you have the notes? Page 102?
Yeah. Yeah.
Not to mention, this goes into it too. Okay. Next is, who can tell me then, what is a fuse part of? A fuse. Let's see your answers. Yes. Excellent. A fuse and a breaker. Last question. What about a rubber wire? A rubber wire. It's a trick question. And the answer, the winner is Georgia. Insulation. Excellent. Yes, insulation. And actually, in your notes, pay attention. There's something I need you to fix. On page 102, you see you have this drawing at the bottom. It says rubber around the wire. I need you to circle and put an arrow to insulation. And I'll explain why in just a second. Well, again, this one, the drawing, put an arrow up to insulator. Why? A protection, everybody, has to do with an entire system. It's more of a overall global picture. So let's say there's a I don't know, a lot of there's a surcharge of electricity on the same part of the house. So you have like the dryer and the microwave all working on the same side. So your breaker will go off to protect the entire electric system. Did you get it? Whereas a rubber wire only protects a specific wire. Like you can still have a surcharge in the house and have rubber wrapped around all the wires. You get it? So in the sense of electric engineering, when I say protection, we're talking the overall system, something that would really stop the current from going, like through and through. Got it? That's why rubber wire is only around the wire, but it not necessarily will stop the surcharge. Okay? So be careful with that. And I have a June exam question from last year about that. Okay, bear with me. A June exam question, where are you? One moment. Right here. Everybody see that? Can you read the question, please? Anyone? Stefania? Anybody would like to read the question? Okay.
Electronic devices contain multiple components with various
George?
electronic.
Okay.
Yes.
Go
With various
ahead.
electrical functions as listed below. Control, protection, power supply, insulation, conduction.
Right.
Which are the
Yeah, go ahead.
which of the following correctly matches each component with its electrical function?
Okay. So, what do you think? Let me put the screen away. This thing. Oops. Sorry. Where did it go? Here it is. Oh my God. 1 second. There. I'll give you guys a minute to answer. You can put your answer on the chat. George, don't just yell out the answer, please.
I won't. I'll save it for someone else to answer.
You can write your answer on the chat.
I will.
Let's see.
Yeah.
Bingo. You guys are so smart. Very good. I have a question for the tolerance. All right. Shoot,
Yeah.
Valentin.
Yeah, so basically the range is 3.9 to 4.3, right? So so how can something that is from 3.6 to 3.8 fit? It would be too small.
Ah, okay. I'll explain why. See, it's really a case-by-case situation. Okay, look. That's why I showed this. In this particular question, okay, imagine the whole, this thing right here is 3.9 to 4.3. Okay? I have to fit a screw that can go through. The screw has to be slightly smaller. Look.
Yeah.
So you see how smaller it is?
Yeah.
Tiny bit. And that's why you had to choose the choice that had a smaller range.
Yeah. Okay.
Okay. I recommend for these questions, draw. If you're a visual person, like you see how by showing you how much easier it is. Okay. So drawing really helps.
Yeah.
See?
Okay.
Okay. All right. Good. Any other questions about the electric stuff? They're pretty simple. Going back to the question, I think it was right here. A lot of you answered D. That is the answer. Because, and I like that no one got stuck on this. Rubber wire is an insulation, not a protection. Okay. All right, guys, let's conclude with a Kahoot.